Experience from the commercial nuclear fleet has demonstrated the importance of managing materials degradation in nuclear systems. These reactors operate under a unique combination of high stresses, elevated temperatures, coolant chemistries, and irradiation.
Experts place the cost of degradation in the nuclear fleet at billions of dollars per year. Despite that, the industry has proven to be very successful in managing these issues and continues to learn and refine these approaches. The advancement of new reactors, often with significant differences in design, chemistry, safety cases, materials, and coolants, brings about an opportunity to redefine and optimize the approach to managing materials degradation.
The ASME Boiler and Pressure Vessel Code has been working on a modern approach for examination and inspection of new reactors for almost 10 years, which resides under Section 11 as Division 2. This new option is known as Requirements for Reliability and Integrity Management Programs for Nuclear Power Plants, or simply referred to as RIM.
Like the rules for the current fleet, RIM defines what must be considered for constructing the materials management program for significant systems, structures, and components for a new reactor. However, somewhat unique to RIM is a higher reliance on probabilistic risk assessment to identify key components for monitoring and inspection. The creation of reliability target values to quantitatively define the acceptable levels of reliability in support of the overall plant safety and reliability requirements. The allowance of monitoring as a key option for managing materials integrity. More formalized use of expert panels where expert judgment is required to fill in the gaps in designer and owner-operator knowledge.
The approach defined by RIM offers the opportunity to think differently, to risk-inform the way we manage materials reliability right from the beginning and every step along the way, to take advantage of new technologies and the latest methodologies including probabilistic approaches and even artificial intelligence, as long as they can be demonstrated to work. But a RIM program hasn't been established yet for any reactor, so there are a lot of things to do and numerous uncertainties.
At EPRI, the Advanced Nuclear Technology Program is actively engaged in RIM, in defining the needs of the industry and building the tools to enable its application, providing guidance to build RIM programs in a robust but optimized fashion, working with vendors and future operators to pilot design-specific RIM programs, and updating the ASME code for future versions of RIM.
Some specific projects at EPRI include developing guidance on requirements of a PRA and establishing the reliability target values, creating the framework to collect and organize all the information required to build a RIM program, compiling materials performance information, and filling in the gaps through testing and analysis, and extending EPRI's steam generator program, the de facto standard for the current fleet, to address differences in design and operation of the steam generators for new reactors.
At EPRI, we're excited by the opportunity to rethink and optimize the way materials reliability is managed. We have a long history in materials degradation management that we will fully leverage.
But this is clearly a challenge that is bigger than any one entity, and collaboration with all stakeholders will be the key to success. If you are interested in this area and not already working with us, drop us a line.